At this point, hopefully you've calculated all of your density values and filled out the table, the data table. If you have not, please do so. And if you have, be sure to check your data table values with the PowerPoint slides. So now you're ready to graph your density and specific heat. The directions say to put the density on the y-axis and the specific heat on the x-axis. You need to determine the interval that you want to go by. You can go by ones, you can count by twos, you can count by fives, but your interval must be totally equal. So I'm going to count by twos for my specific heat. And I'm going to count by threes for my density. The criteria for the intervals is that they need to cover the entire range of the data. So all of our data points need to be able to fit on our graph, and they have to be equal. If you choose to count by twos, then that entire axis you need to count by twos. So I'm going to plot aluminum with you. So the specific heat for aluminum is 0.903. So that is our x-axis. 0.903 would be a little bit before where 1 is, so somewhere on this line. And our density for aluminum is 2.7. Okay, so that's a little below 3. So that'll be somewhere on this line. And so I'm going to pick my point where these two lines meet, and this right here will be my aluminum point. So go ahead and graph the other 4 substances. When you finish graphing, you should notice a trend. You should notice that when we have very high density, like gold, we have a very low specific heat. And when we have a very low density, like hydrogen gas, we have a very high specific heat. So based on that information, go ahead and complete the claim of the CER for number 8. For your CER, you need to make sure to have all 3 parts. So your claim should answer the question, does density increase or decrease when specific heat increases? Your evidence, you need to include at least 2 data points to support your claim. Be sure to relate the data points to your claim. Okay, make that connection. And your reasoning needs to explain, why does this happen? So let's talk about the why. Why does this correlation happen? If we have 2 substances of equal volume, and they both have, this one has 4 molecules in it, and this one has 11. Which one is more dense? We will call this A. Oops. We will call this A, and this one B. Hopefully, you instantly know that B is more dense. These molecules, these dots, these particles are more closely packed together, which means it is more dense. So if we were to expose both of these to some heat, there's my heat, that heat would cause these molecules to move. These molecules would start jiggling around a little bit. So here they're moving. Only the molecules right next to the heat would start moving. In our box B, as soon as those first molecules move, they are so close to the next molecules that they cause the next molecules to move. Just like, it's like a domino effect. Those first molecules will quickly bump into the next molecules, which will bump into the next molecules, and pretty soon the entire substance will feel really, really hot. In A, these molecules will move but they're not as close to the other molecules as the ones in B. So it's going to take a little bit more heat. It's going to take more energy. We need to put more energy into A to make these molecules move fast enough to heat the rest of the substance, to make that whole substance hot. So when something is more dense, it takes less energy to heat this whole substance, so that would mean a lower specific heat. If something is less dense, the molecules are further apart, so it will take more energy to heat that entire substance. So less dense takes more energy, so it will have a higher specific heat.